Click on Project, click Create Start Configuration Scheme. The first step triggers the configuration by default, where the communication string is started default. Click Auto Adjust to automatically adjust the camera focus and brightness. If the light is not enough, set the brightness standard to medium and click Auto Adjust. Click Next when the focal length and brightness are adjusted successfully. Click Next when the focal length and brightness are adjusted successfully. Click the plus sign to select the 2.5D location tool from the Location tool. Click the Open button of the Calibration tool to configure the 2.5D positioning tool. Click on the bottom left corner to select English language. The connection is successful if the robot is disconnected and becomes connected. If the robot keeps showing the robot disconnected, make sure that the robot mode is switched to configuration mode and that the camera software is configured correctly. Click Photo to confirm that the calibration plate is in the center of the camera field of view. During calibration, it is best to adjust the robot to the level between the camera and the calibration plate. After determining the calibration position, record the robot position as the camera shooting point. View the calibration board type, select the calibration board currently in use. Fill in the distance between the camera and the calibration plate. Click Auto Calibration and the robot will automatically calibrate. Calibration status indicates successful calibration. Pay attention to the hand-eye calibration error. If the maximum error is greater than 0.8, the average error is greater than 0.5. In the case of high accuracy, you can choose to recalibrate. Click Next. Place the marker in the center of the camera's field of view. Click on Phasor Benchmark to register. If the identification is successful, the registration status indicates that the identification is successful. The calculated distance is the true distance of the mark code distance camera. After the registration is successful, click Save Configuration. The calibration parameters and reference poses can be saved to a XIM file. Click Finish and Exit. Import the saved configuration file. You can click Test Run to see if the configuration file works properly. If green OK appears, the operation is successful. Click Stop to complete the test. Click Close. Click Next to enter the output configuration page. Open the output and click Edit. Click Add. Select Data Find to 0.5D location. Select Identify the resulting data. Empty the semicolon in the separator to complete the output configuration. Click OK. After clicking Done again, the Solution Save pop-up window will pop up and fill in the solution name. Enter the solution name and click OK. You can also select a saving scheme during the configuration to prevent data loss after an abnormal shutdown. Click Project to select the switching configuration and change the switching mode to communication switching. After modification, click OK to configure the solution switching as communication switching. You can test whether the currently configured solution can run. Click to run Vision_Test1 once. The green OK display indicates that Vision_Test1 is running properly. Finally, click the Run button to run through the communication triggering scheme of the robot side.